When I think of Earth, my mind is filled with the diversity of life and the rich flora and fauna. In reality, about 99% of Earth is uninhabitable. Deep underground places with high pressure and temperature where even the toughest bacteria cannot survive. There are places, though, where life thrives from tiniest, toughest bacteria to the largest elephant. Then there are places that are habitable but devoid of life. A paper recently released looks at these habitable areas and wonders what we may learn as we search for life in the universe. Life on Earth has taken millions of years to evolve to the state we see today, and has invaded nearly every corner of the planet. That is, except those places where the environment is so extreme that even the toughest extremophile cannot survive. These regions include places like the Atacama Desert in Chile, one of the driest places on Earth, where rainfall is so rare that even microbial life struggles to survive. Similarly, parts of Antarctica's dry valleys feature sub-zero temperatures, minimal liquid water, and high salinity in some soils, creating an environment hostile to most life forms. It raises interesting questions and perhaps poses limitations on life's ability to survive. We can learn a lot from life on Earth as we hunt for life elsewhere in the universe. At the moment, there's just one place in the cosmos where we know life has evolved. That's on Earth. A paper recently authored by Charles S. Cockle from the University of Edinburgh explores what we might learn from the inhospitable places on Earth and how that might inform our search for extraterrestrial life. The paper discusses places where active microorganisms cannot be found, in particular those places where the physical and chemical conditions are not far from areas that support life. The physical spaces where microbes cannot sustain the essential metabolic activity or even reproduce can be categorized into two groups: those with uninhabitable conditions and those with habitable but uninhabited spaces, also known as uninhabited habitats. You might need to read that a few times, but it does make sense. Uninhabitable conditions occur in environments where life cannot exist due to extreme factors like intense heat, cold, salinity, or acidity. In contrast, uninhabited habitats are environments that are theoretically capable of supporting life, but remain unoccupied, often due to barriers to colonization or the absence of necessary organisms. The paper draws a strong differentiation between these vacant niches. These uninhabited habitats, which form on both macroscopic and microscopic scales through diverse processes, offer opportunities for scientific investigation. They can act as negative control environments, helping to reveal how living organisms influence geochemical processes and how they can provide a framework for studying processes like microbial succession and community development. Despite their potential significance, the occurrence of these habitats in environments at the physical and chemical extremes of life remain poorly understood. As we continue our search for life across the universe, we may find many more locations like these. Doing so will help to expand our understanding of the distribution of habitable conditions and the potential for life across the universe. They may offer insights into the processes that make a location suitable for life, as well as the factors that have prevented life from arising or persisting there.